Don't worry, Flat Earth Core. This video ain't about you. This ain't your hoe. This is my hoe. Hoe comes from FECU. It stands for hydroflowmatic oligoorientational horizontaliser. HOH, pronounced hoe. If you put three of them side by side, you can say, now I have surveying equipment. Ho, ho, ho. This is really simple and not going to look its best because I have very limited display space because, you know, I haven't committed enough tax fraud to be able to afford a larger home than this, or, you know, go and do this on a motorboat on Lake Ballaton or something. But very simple construction. It's got 8 of these 3-way elbows. It's got just one T-piece, an end cap, which is probably unnecessary, and it is 10, allegedly 1 metre, lengths of pipe. This is the 1/2 inch size. I got these from plasticpipeshop.co.uk. They're in good condition, it's exactly what I ordered. They included the glue that I didn't need. I thought I might need glue to stick the pieces together so they wouldn't leak. And I thought, if I glue it together I can't take it apart and move it. I hope I can seal it well enough with Vaseline. Actually, if you look closely here you can see this isn't all the way in. I have the opposite problem. These are a very tight fit. So if you're planning on making one of these, plan in advance to file the ends down. They are kind of full of dust. Also kind of difficult to focus on, but there are little bits, some of them from me sawing through it, some that were already there. These are supposed to be 1 metre lengths. They're actually about, no, they're not 1000 millimetre, they're about 97. Yeah, they're about 997 millimetre. So just slightly short. If you saw a 50 centimetre length off one of them, you won't get 2 50 centimetre lengths. You'll get a 50 and about 49.6, 49.7, depending on the width of your saw blade. I've got 10, not 12, because this is only 1/2 metre high. Top and bottom corners are only 50 centimetre lengths, or 49.85 centimetre lengths, because it saves money, it saves bulk, it saves weight if you're going to carry the thing up a hill. If you're confident that you're going to have somewhere flat to lay this, flat, hey, level, both, near enough to both, as they are pretty similar over a mere 1 metre. If you're confident that you are going to be able to get it laying level, then you don't really need this full 50 centimetre height. All you need would be 25, get a single 1 metre length and cut it in 4. Or even less, you could make it just 10. As long as you can get this upper vertex above that lower vertex by a sufficient margin to have some of the bottom of that pipe and some of the top of this pipe at the same level, or the same thing on these corners, you can get the water level to be in the approximately vertical parts. I would still say it's better to get it as near to upright as possible, because obviously these pipes have thickness. If you take off this end cap, you can see there is a thickness to this pipe. It's not vast, but it's there. It's maybe 2 mil. And the pipe has an optical density. You can tell because there's all this refraction going on. Putting images of my kitchen units here and making a mess of images of the view of the washing machine door. There is refraction, therefore there is a change in optical. Well, there is refraction, that's the issue. If you're looking at it at an angle, it won't be this severe an angle, but an angle, your line of sight through it is refracted. So the water level seen inside it will be seen at an angle that isn't the angle at which you're viewing it. Right. If you get it exactly level, excuse the mess, if you get it exactly level, you don't have that problem. So the nearer to level you are, the more accurate you'll get the height of the water level. The idea, of course, of this thing is that water finds its level. You use this to fill it. Pop off. The end cap is probably an unnecessary expense. Making all the sides the same length is actually unnecessary precision. This thing could be skew-whiff all over the place, it wouldn't really matter. The idea is you fill it through here to get a water level that's visible in all four uprights, or get custom joints made. You don't have to use right angle through elbows, you know, you could get these things at 72 degrees, make it dodecahedral. Yeah, you can still only fill it with one liquid, by the way. If you make it dodecahedral and pour water in to get one level and then pour oil in to get another, you can't guarantee you have the same amount of oil. Let me just think about this. No, that would work. But you have to keep the water level below the lower set of middle elbows and get the oil level above the upper set of the middle elbows. Otherwise, you can't guarantee you have the same amount of oil in each leg. If you added water and oil to this thing, you would definitely have the problem that you could have different amounts of oil in each leg, and therefore the water levels and oil levels would be different. Just use one liquid, have it well mixed. Keep it simple. Avoid introducing problems to your tests. The lid is there so that the wind can't blow into this and create air currents blowing around the upper pipes that will create differential air pressures that will interfere with your test. It's not necessary. Through pipes this small, especially, if you use the 3/4 inch or 1 inch, inch and a half, which is getting more and more expensive, and requiring more and more water to fill it, you might be on a hilltop without an actual supply of water nearby and having to carry it up in bottles. Anyway, once you have your water level there, you can look that way and back this way, and that way and back this way, and diagonally from there to there, and from there to there, giving you north, northeast, east, southeast, south, southwest, west and northwest, or another set of angles, some consistent amount clockwise from there, levels. You can see better if I zoom out, yes. From there to there is actually level here in the centre of the device. From there to there is level here, halfway along the side. So there is a slight difference, but fortunately that diagonal and that diagonal level here are level in a plane that level here parallels, and level back here also parallels. So you have one plane which is those two diagonal levels, and another plane which is these two. Orthogonal, sorry about mentioning that word, levels, or these four. And that side and this side are parallel. If you make it slightly skewed, they won't be, but they'll be parallel in one dimension. They might cross over that way, somewhere way over there or way over there, but they'll both be the same level. One isn't going to go above or below the other. And if you do the actual calculations for half a metre from here to here, that's 1/80,000th of the circumference of the Earth. So 360 divided by 80,000 equals, and press the cosine. In fact, you know what? Let's go back. Earths are idiots. Yes. Flat Earth core, idiots. But let's have the calculator up. It's prettier than them anyway. It is half a metre, 0.5 metres. divided by, open brackets, circumference of the Earth is 2 times pi times local radius of the Earth is about 6363636 meters. Close brackets. There you go. 40,000. Near enough. Yeah, that distance is 1/8 of 1/10,000,000th of the circumference of the Earth, making it 4.5 microdegrees, the cosine of which is pretty much 1. .6 nanometers. Too small to be a virus. There isn't enough room between those two planes to squeeze a virus in. You might get a protein through there. And does anyone think this camera can even see things that small? You can't see things that small with visible light. It doesn't matter how good your camera or your microscope is. You couldn't even see that in ultraviolet. Let's get something prettier than these lunatics on the screen. X-ray wavelength. 0.1 to 10 nanometers. So you could see it with X-rays. You could actually measure that distance with X-rays, but nah. So anyway, here we have a thing with no glue whatsoever, no fancy work. I had to make 4 cuts. I had to cut a pipe in half to make the uprights, another pipe in half to make those 2 uprights. I had to cut this pipe in half to insert this. This one doesn't have to be halves. Well, these don't have to be half, it's just nice to get it orthogonal. This, it could be over here, it could be way over there, it could be anywhere. In the middle is nice, it doesn't matter, especially with the end cap on, so that wind isn't going to change the air pressure in the part that it's in, way over here, affecting this corner more than that corner because the pipe offers resistance to the flow of water. So this can be anywhere, but you do need to cut this pipe to get an end you can insert in there and then you can insert there, and because of this gap here, between these 2 sections of pipe, to get the total length down to the same as that side, I had to remove an extra piece, which is this bit here, which conveniently lets me put on the end cap to shut the wind out. But that is it. That is all you have to build. Fill it. When you're done taking your photography, just pick it up and tip the water out, because it's only going to take maybe 5 litres. It's got a pretty small internal bore. As for measuring horizon dip angles or dip angle to the next ridge, if you're standing on a particular point on a particular ridge that's at the exact same elevation as 2 hilltops, one each way along the mountain range, as long as they're far enough away, there should be a dip angle to each of them. If they're at the exact same elevation, they should both be below eye level. And the idea here, and I apologise for not having a big enough home to set this up. Wow, there you go, packaging waiting to be recycled, and packaging waiting to be used to bring back more beers, and somebody gave me some apples. No idea. But the idea is that you could back off to a known distance and get pictures like this, or video, or both. And it won't matter whether you're looking through the centre of it, or level, or off to the side, or whether you hold your camera slightly tilted, because you will have all 4 water levels. Food colouring might be a good idea. Adding food colouring might be a great idea so that you can see it more clearly. Now, all 4 water levels, so on your picture you can draw a line across them, And as long as you have your camera at the correct elevation, the elevation not level with the water there, the own level that the water has found, then all four of those should be in a straight line. If they're not, well, you got it wrong. But of course, if you're taking video, you could just sort of very slowly change the elevation of your camera. And then just use whichever frame has them in the straight line. Just go through it frame by frame, trying again and again until you get them perfectly lined up. You can also do it that way. And there's a reason for this. There is a reason to do both. You'd have to be further away than this to get all four in. If you have your camera 10 meters away from the center of this object, and you measure that 10 meters, and you know that this, 10 meters away, and this is ½ an inch wide. That's good. I like mixing meters and inches. Yeah, make it 10 yards away and ½ an inch wide, or make it 10 meters away and call that 12.7 millimeters, or actually measure it. That might be a good idea, actually measuring it, because they weren't really meter long sections. But you can get a pixel count for that width at, oh hang on, not 10 meters from the center, no, 10 meters from one of the pipes. Sorry, 10 meters from the pipe, you can get a pixel count for the width of the pipe in the screen, and then use that pixel count that way on to tell you how many millimeters, or what fraction of an inch, down the side of the pipe, the distant hillside, or the horizon if you're looking out over the sea, is from the water level. If you've got the water levels all lined up in a straight line, your camera is on the level with the water. If the horizon, or the distant hilltop at the same elevation, is below that, you can see how many millimeters at the known distance to the pipe it is. And then of course you have a very simple piece of trigonometry. Let's say it's 15 millimeters down, divide that by your 10 meters away, inverse tan, that's the dip angle. And likewise you can you can count the pixels across the width of that pipe, and it's a circular section pipe, so it doesn't matter what angle you're at. If you're at the same distance, the width, the angular width will be the same. Specifically, it'll be twice the inverse sine of the radius of the pipe divided by the distance from the camera to the centre of the pipe. And use that in your footage taken this way up to get, hopefully, the exact same result. And really, ideally, you would get the same pixel size whichever way up. If the camera isn't distorting things, then from way back here, so I don't change the distance much, the pixel count across one of those pipes now shouldn't be changing as I do this. You should have the exact same pixel count with the width of a pipe at any of these angles, and as I do this. Is that vertical on the screen? Not left hand one. Yeah, it shouldn't change, so you should get the same result both ways. But it's good to do it both ways to check, and that will give you a horizon dip angle, or a distant hilltop dip angle. The reason I mention distant hilltops is that you can have a known distance to a distant hilltop, but you don't really have a known distance to the horizon. It's difficult to arrange that. Not sure how you would accurately. I mean, without calculating it based on a known radius. So having a known distance to the hilltop and a known dip angle, you can then, again, trigonometry, it may take me a while to think of what trigonometry you do, but the dip angle to the horizon has a cosine of the radius divided by the sum of the radius and your elevation. The dip angle to another object at the same elevation as you should simply be the distance to it divided by the circumference of the Earth multiplied by one circle. So 2 radians or 360 degrees, whichever unit floats your boat. Right, now buoyancy and density float your boat. Whichever unit stokes your goat. Right, stoke your goat. So if you know the distance and you know the angle, you can divide the angle by a full circle and multiply the answer by the known distance to the hilltop at the same elevation as your water level here, to call out the circumference of a circle with a radius that is the distance from the centre of the Earth to you. So you would then divide by 2 times pi and subtract your known elevation above sea level to get the radius of the Earth to sea level. Yeah, that should work. Should work just fine. I just need to find a high place with a view. High place with a good view. Maybe up a mountain somewhere near Budapest. Could watch the speedboats on the lake and think, gosh, those people sure are wasting a lot of money.